Okay. All right, guys. Well, welcome to Grand Rounds number 2. Actually, let me see if I can get my own video on here. Ah, very nice. All right. Today we're going to talk about a student that's going to illustrate the importance of the kernel. And I'm going to show how the kernel was developed. And this was a student who was, to say that he was traumatized is like understating his experience with education. This is somebody who is just in every way made to feel like he was just didn't know anything, like he was stupid. It's just the worst possible educational situation. Just a really bad situation. And using the kernel in a period of a fairly short amount of time, we're talking about a couple months, like 2-3 months, we were able to massively increase his understanding of many, many parts of math, essentially getting him caught up to grade level and then a little bit past. When we started out, when we started out, he didn't know just like any math at all. No two-digit multiplication, no one-digit multiplication, really. No multiplication tables, no fractions with like denominators or unlike denominators. So, he came in knowing functionally nothing. So I want to illustrate how we specifically used the idea of the kernel in here. And when I say a kernel, what I mean is some core piece of knowledge, some core body of knowledge that you could then add things to. So we started off with really, really, really basic things. Some of the first things were just drawing fractions and with just drawing a circle and having them identify how many, whether it's like 1/5 or whatever. Having them do very, very, very basic equations and then going up to two-step equations. Now, what I noticed very early with the student is that essentially he would, whatever he learned in one class period, he would certainly forget by the next class, by the next session. And also whatever he learned in the first half of class, he would forget by the second half of class, et cetera, et cetera. So I want to show you a little bit about how we built the kernel. I'm going to show you with a few different topics that we use. Because we use this technique fairly extensively. I want to start off by talking about multiplication tables, right? At the beginning, he didn't know any of them. He could do kind of the 2 multiplication table, but not much beyond that. So I would ask him just a few questions, a few multiplication questions, and he'd gotten the idea that you could add up numbers to get it. He would routinely add them up incorrectly, but if he got it right, give him some encouragement. And here's the key, and here's where the kernel comes in. So let's say that we're talking about 7 times 4. I would ask him 7 times 4 many times during that session and many times during the next session. And this is the critical part of the kernel. The kernel is not based on taking a given concept and building up that concept. It's taking like a given fact and building on that fact. So in like a 7 times 4 case, the kernel here is not multiplication. The kernel here is 7 times 4. So in other words, we're repeating the same question many, 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 many times. Same thing when we're dealing with negative numbers and stuff like that. I would ask them a question like, it's 10 degrees. It's negative 10 degrees. It gets 1 degree warmer. What's the new temperature? And I would ask him that same question, like the literal same word for word question, quite a few times to build up the kernel. Any questions about any of that so far?
I don't have any.
All right, cool. So
I just want to jump in really fast.
Okay, Chelsea.
This last part is really like one of the most important things to emphasize. The kernel is not a general body of knowledge. The kernel is not like chemistry. The kernel is not even algebra. The kernel is not arithmetic. Like, it's nothing even remotely that big. It's not like, oh yeah, if students could just know arithmetic, then we could build on that. It's not that. The kernel is literally anything in the world that is one singular tiny fact that has one singular, very, very clear, non-negotiable answer. So it's like really, really tiny. And it can just be anything at all, right? So I worked with a student the other day, and the kernel I was using was, a couple of squares, right? So I actually had, 2 or 3 perfect squares that I would ask her, on repeat throughout every single class. But from there, literally in 2 sessions, it was like night and day. And all of a sudden she could do everything inside of special triangles just because she knew for 100% certain. She knew that she knew the perfect squares of, whatever it was, 7 squared and 15 squared or something like that, right? She knew that she knew something. And psychologically, that is just so massive. So again, making sure that's really, really tiny, something that the student can know for sure that they know for sure, not something that they might be ambiguous about, like, oh, I don't know this. Like, well, I think this instructor kind of accepted that answer that one time. I don't know, like nothing like that. So yeah, go ahead.
It's actually good that you brought up perfect squares, because I think intuitively Chelsea and I have come to the same actual technique. So with the student that I've been talking about, that was actually one of the major core points that I would quiz him on every single session, starting with 7 times 7, because obviously 7 multiplication table is by far the worst. 7 times 7, 8 times 8, 6 times 6, every single class, many, many times. Perfect squares are a nice thing to use to build up the kernel of multiplication. Of course, multiplication tables are a nice thing to build up the entire system of arithmetic and mathematics. I want to talk a little bit about how we address some of this stuff emotionally, because people are going to say, well, why am I doing the same stuff 5,000 times? So in this particular case, and also with many other students, what I do is I emphasize one thing. So in this case, I let the student know that the multiplication tables are the most important skill in all of mathematics. Then later on, I tell them factoring is the most important skill in algebra. And then they'll say, wait, I thought you said it was multiplication. And of course, say exactly, because factoring builds on multiplication. Multiplication is the most important, factoring is the most important thing in this subset, but they're so deeply connected. The other psychological aspect of that is whenever we were doing anything, like anything at all. So if we're doing adding fractions, right? In order to add with unlike denominators, of course, you have to use some kind of multiplication. And I would stop and emphasize how important multiplication tables were. Here's another area that shows how important they are. Here's a third area that shows how important they are. I was constantly showing them that this kernel is not just manageable, but vitally important. And that's super key. The way that most people understand math is not how any of you guys understand math. All of you guys understand that math has more and less important things. The way that most people understand math is a series of like equally important, nearly entirely unrelated random formulas. That's how people see math. And to start to change that really requires that you not only have a kernel, but that you hammer home the importance of that kernel. Does that make sense to you guys? I'll take that as a most definitely yes.
Yeah. Also, so this is a lot of the stuff that we are doing in the curriculum. So as you're going through the new curricula that are coming out, you will probably see certain things that are being repeated. We're not really doing the exact same question, but we might start adding that in a little bit. But the idea of the kernel is still throughout. So it's a thing to think about that's there. If you're looking at, critically at the curriculum that we're developing, it's a thing to think about as well. But also when you're teaching with the curriculum, definitely it's a thing to keep in mind. So anytime a student is struggling at all, like literally ever, your first instinct should be, okay, what do I want the kernel to be here? And then ask that one question, just figure out one question and ask that question every single time the student gets something wrong. So, this idea that we often think to ourselves, okay, I tried teaching it this way. The student didn't get it. So that didn't work. I obviously failed. So I'll have to come up with something new. It's not that, right? What we really want to do is just hammer home the exact same question like Arvin's been saying. And you just say, okay, in this thing, I really think the most important thing would be that they know their squares. So I'm just going to ask, what's 7 squared? What's 9 squared? What's 12 squared? Cool. Then they do the next question. They're struggling. I say, okay, well, let's review. What's 7 squared? What's 9 squared? What's 12 squared? Awesome. You got that. Now let's build from there. And literally saying those things out loud to the student so that the student also internalizes that they got that. They've got it, And building on top of that, it works in almost every area, right? If you're struggling to find what you think the kernel should be, that is absolutely what I want you guys to think about and start to talk to me about as you're going through students this week and the next couple weeks. Looking at it and saying, hey, the student was struggling. I don't know what the kernel was supposed to be in this situation. So what do you think? And I'll tell you. Yeah? Cool. Back to you.
So we've seen effective uses of the idea of the kernel, and we've also seen ineffective uses of the idea of the kernel. So the big ineffective use was, of course, the review system. And so I want to talk about why the review system that, well, I don't say we built, but that I built, uh, while it attempted in spirit to go to build a type of kernel, actually failed very, very massively. And here's the big thing. The review system would explode into 20 or 30 questions, but a kernel is not made of 20 questions. It's made of a question. So one of the things that we've done to make the reviews much shorter and much more manual is to say, okay, we're going to review 7 times 7 at the beginning of every class, not we're going to review these 700 questions. A kernel cannot be composed of 50 different things. It can be composed of one different things. So let's talk about how to use. Does that make sense though? The difference between a real kernel and the false kernel that came out of the review system. All right, cool. So let's talk about how we use kernels in verbal type things. So one of the things that has been really interesting for me working a lot more students on reading is the extent to which the most basic idea of a thing gets totally forgotten. And you'll see this inside of Persuasion World. Like many people, when they do their first Persuasion World paragraph, where they have to write their own paragraph, they'll completely forget everything they learned about Persuasion World and go back to something like, pathos, ethos, and logos, or something like that. Stuff that they learned in school that's mostly nonsense. So what that shows, though, is two things. One, it shows the ineffectiveness of the extent to which we've built the kernel, but it actually also shows how effectively their schools have built a kernel. Maybe not a great kernel, but still a kernel that they have over there. So what happens with something like this is it gives us an area where we can pick one thing to emphasize. So I'll give you some examples of a few single things that I've emphasized with students, especially in tutoring. One is individual vocabulary words. People will just forget vocabulary words from one session to the next, and that's no surprise to anybody. So what I'll often do is, especially if it's a complex vocabulary word, a word like utilitarian, because it has so many other things, philosophical connotations, it's like a complicated word to think about. So words like that will often take like a month or two for students to really internalize, understand how to use it, what it means, all that kind of stuff. So that's an example of something that can be a kernel, a single vocabulary word, or a single idea that in order to be persuasive, you need to appear neutral. That's like one idea that you can hammer home again and again and again. Does that make some kind of sense? I'll take that as a yes. So in other areas, the idea of the kernel is going to be very connected to the idea of visualization. When something is truly going to be a kernel, it's not just something that somebody can understand, it's something that they can picture. So a lot of times when I'm working with a student on a kernel, if there's something that can realistically be drawn, like not like it's something nonsensical, I'll have them draw it out. I'll really emphasize that from many different angles. But ultimately, even if we approach it from a couple different angles, ultimately the core of it is repeating the literal exact same question many, many times until they are confident with that one question. Because if you're confident with one thing, then you can learn how to be confident with other things.
It's largely the premise of the math program since its inception, by the way. And it's really crucial to think about this pretty much in every single subject. I'm not sure there is a subject that this doesn't count towards. But, in math in particular, people often talk about, I felt like I was like learning these, very applicable skills because they are. Like the point of the questions in math paths is not that these are the most important 12 questions you need to know. The point is if you know those 12 questions super, super well, it just opens every single other door for you, right? And that's what we know, having gone through it and done all these questions so many times, and we like just deeply internalize them. And even, the same 12 passages that we have in the reading curriculum, it's the same idea that we have created our own kernels for ourselves also. So, just like other places where this comes up, right? But it really is everywhere. And it's going to be a really useful tool to create live on the fly a little bit as well.
Anyway, so I think that's basically the gist of the kernel. Chelsea, is there anything else you feel that I should go into on this?
I think that's awesome. Yeah.
Okay. All right, fantastic. All right, thanks very much. Does anybody have any questions on this?
Hi, I came a little late, so maybe I missed something, but is the kernel for like every single like idea, or is it just if a student is struggling with something?
Sorry, go ahead, Chelsea.
Yeah, it pretty much can come up anywhere. I mean, if a student isn't struggling and is getting it, then they don't necessarily like they either already have a kernel built or they just don't really need like help with it. You know what I mean? So, but yes, like anything, anywhere in the curriculum, there could be a kernel developed. Even when I'm walking students through, some of our hard passages and things like that, I'm always thinking, okay, what is the core kernel here? And that's where we get some of those reverse Turing questions and things of that nature, where, if you come back to that repeatedly, okay, was this person on this side or the other side? Okay, we know that this person was on this side, so from there, what can we assume about like whatever, right? But just coming back to that same question again and again whenever they get something wrong, it means that at least they walk away from a passage or a worksheet or whatever with like one thing learned, just one thing. And then if they have to review it later, hopefully they still have that one thing with them, and then they can get a second thing and a third thing and whatever, and it'll grow exponentially, as most learning does.
I want to add a little bit to that though. So when you're working with students on things like, I don't know, like school math, chemistry, physics, and they're getting straight A's, especially if they're getting like straight A's on their quizzes, like they're getting 100% on every quiz, that to me, high quiz grades to me are always a massive red flag. 'Cause high quiz grades often mean that the student is learning a thing and then forgetting it, like thoroughly mastering a thing and then forgetting it. So whenever I see somebody that's not struggling with a thing that normal people do struggle with, so for example, with physics or calculus, that like normal people find it difficult, and someone's like just knocking it out of the park, to me, I want to check on that. So with calculus in particular, I will ask students just every single calculus session, every tutoring session, the entire year, what does the derivative tell you? And you'd be shocked.
That's the best one.
What's that?
That's like the best question for calculus.
Yeah. And yeah, I mean, you'd be shocked. I mean, people will be like, way in the middle of integrals, doing all kinds of advanced stuff, and they're like, "Oh, I don't know. It's just like, you take this number down and reduce the exponent." So that kind of stuff is so. Even if a student's doing well, I still like to make sure that I'm checking the inherent kernel of that subject a lot.
And so, in terms of growing the program, you guys are an active element of that. So as you're going through and finding these kernels, for each individual topic or whatever, for each student, you can come and report back to me and say, hey, like this was the kernel that I was using. Do you think it was good? We can discuss it. And then also, if it's good, we'll add it to the program, right? So that's why the calculus program, the new version of it that's going to roll out in a few months, is going to heavily focus. I mean, it asks that question, what does the first derivative tell you? Like 17 times. Why? Because that is like a very intentional kernel that we want to build, right? So that is kind of how these things get rolled out in the curriculum as well. So yeah, you have an important role.
And so I want to add one more thing, and this is just a technical thing. One of the ways that we build the kernel is, of course, by asking it. The other one is, don't be afraid to use the /postcard command. The /postcard command is for kernels. So if a student is like, say, working on 7 times 7 equals 49, you can just type /postcard 7 times 7 equals 49. You can have them send it to their parents, send an email to them, have a physical postcard mailed to their house, all within a couple seconds. That is what that thing is for. It's not for like weird and fancy things. It's to hammer home anything that could be qualified as a kernel. So if you're working with a student on a kernel, feel free to use that /postcard command.
It's like so awesome when it gets there. This is really, really cool. All right, guys. Any last questions about any of that stuff or anything else? Will take your unwavering silence as a no.
All right, awesome, guys. All right, thanks so much for coming in for this, and I'll see you guys next week. Well, I'll see a lot of you guys in class in 20 minutes, but I'll see the rest of you guys later.
Bye.
That's it.
Wait,
All right,
or
thank you.
don't go.
Okay, I'm not going.